All right, well, let's get started, everyone. Thanks for your interest in joining us for this first that I know of SOGIS webinar. Thanks to the School of Global Environmental Studies at CSU and especially to Laura Shaver for helping us organize this event. I'm Joe von Fischer. I'm a professor at Colorado State University in the biology department. My research is really about what gives the atmosphere its greenhouse gas composition. And everybody, all of you, I'm sure, have a favorite gas. My favorite gas is methane. You know, it's a great conversation starter or stopper, depending on the people's response. I'm joined on this panel by a couple of other experts who I'll let introduce themselves. Grace, why don't you introduce yourself for us?
Hey there, I'm Grace Hood. I work at Colorado Public Radio. I cover climate, and I was actually going to say, Joe, that methane was my favorite gas as well.
No way.
We have to arm wrestle over it. But I've covered climate change for the last 5 years, and boy, what an interesting story here in Colorado. A lot of rollbacks at the federal level, but at the state level, a lot of climate successes at the policy level.
Fascinating. I can't wait to hear from your presentation here. Sybil, do you want to tell us about yourself?
Sure. Hi, this is Sybil Sharvelle. I'm a professor in the Department of Civil and Environmental Engineering. I work a lot with resource recovery, which includes looking at how we can recover resources like methane, everyone's favorite gas, from things like manure and food waste and things like that. And I look at a lot of other elements related to resource recovery, but that's kind of the focus today.
Thanks, Sybil. And Dan, tell us about your work.
Joe, I do not have a favorite gas. In fact, I don't even have the bandwidth to think about what my favorite gas would be. Anyway, I'm the director of the Methane Emissions Program in the Energy Institute at Colorado State University. We do a lot of field work on the emissions from natural gas. We also run a test facility on the Foothills campus, one of the largest in the world, where we test leak detection and repair processes.
Good. Well, we'll hear from Dan later too. Once again, for those of you just joining us, here we are at the School of Global Environmental Sustainability webinar about natural gas leaks and the impacts of those leaks and what, at least in the state of Colorado, what sorts of things are happening to manage those and how those pushes are potentially leading to an opportunity for additional renewable natural gas generation here in Colorado and elsewhere. Just to orient you here, we're on Zoom, as you all know, and probably not your first time on Zoom for many of you. I would like to point out to your attention at the bottom of your screen. If you move your mouse down, you'll see a Q&A option, question and answer option. If you're in the audience, please feel free to use that to pose your questions. We'll try to get to those as this webinar unfolds. The sort of framework that we developed is that we have a series of short presentations that I and Grace and Sybil have pulled together, and we will present those briefly, and then we'll have a little bit of a roundtable discussion between us, a panel discussion, and we invite your questions of the panel, things you're interested in or have wondered about. We can either wonder with you or perhaps supply some kind of answer to address your question. So please feel free to use that, and we'll try to get to the question and answer as the panel goes on. You know, I'm always scared. I'm about to share my screen and show my presentation, but you never know if I'm going to show you my Amazon shopping or what. So we'll see how that goes. So what I wanted to do with this was to, oops, here we go. You see this now? This is my PowerPoint presentation, just a few slides just to provide an overview and backdrop for how we ended up thinking about a SOGIS presentation about natural gas. Natural gas leaks have been in the news a lot. They impact air quality, and there is a lot of interest right now in how, in the development of renewable energy supplies. And so in part of that backdrop, I want people to realize how important natural gas is as part of our economy right now. So this is a stacked little bar graph showing between 2000 and 2018 where the US energy supply came from. And you can see that green bar of natural gas from 2000 to 2018 has increased a lot. Natural gas is a much bigger part of the US energy supply. And then if you look at the very top, the pale pink bar, which was very small in 2000, but has increased by fivefold, is the wedge response that we can attribute to biofuels. So biofuels have increased in their proportion of contribution to the US energy demands. And so we are interested in to what degree that biofuels wedge may increase further in the future as we look to a more sustainable type of economy that's built on energy supplies that are renewable and not so strongly driven by natural gas sources. As a reminder, the US economy depends on these sources. And so when we look at where this energy goes, electric power is one of the largest consumers of these energy sources, most of which are petroleum-based. Coal has been declining. Natural gas, due to its lower cost, has been increasing over time. And Colorado, as we all know, is one of the places where natural gas production has really taken off. If we look at the natural gas system and what natural gas is a mixture of gases, actually. And I think we often talk about natural gas and methane as being synonymous, but they're not exactly. Methane is typically 90 to 95% of natural gas, and the remainder is this mix of other hydrocarbon gases. These include ethane, propane, butane, hexane, and there are a number of other gases that are included in this mixture of what we call natural gas. Natural gas, through the process of production and transmission and delivery to end use, relies on a really complicated network of infrastructure and machinery that people put together to move natural gas from the ground out to the end use. But along that path, not all the natural gas stays in the pipe. And so in this middle panel, I show a small break in one of the distribution lines that might carry gas to a home or a business. On the right panel here, I show an infrared image that was taken with a type of camera device that shows natural gas leaking from the top of a production facility. And on the left, I show another infrared image of a massive leak, a blowout, and the Aliso Canyon natural gas storage site in Southern California. These types of emissions can obviously range from small to large, but when the gas doesn't stay in the pipe, it makes news to varying degrees, and there are a couple of major reasons why it does. One of the big reasons why we worry about methane is because it's a potent greenhouse gas. And I wanted to take a minute just to remind everyone about how methane works as a greenhouse gas and how the greenhouse effect works. As we all know, we're enjoying a warm, sunny day in Colorado here, where the sun's heat is shining down on the Earth's surface and warming it. And if you've ever walked by your oven and felt the heat radiating off the oven, you know that warm objects emit heat. And this heat is actually emitted in the form of photons. They're just invisible to us. We call them infrared photons, but they are still a form of radiant energy. And then the Earth is basically cooling itself by releasing these heat photons back up to space. As the concentration of greenhouse gases in the atmosphere rises, these gases like methane and carbon dioxide trap heat that's making its way up to the atmosphere and up to space. And as a result, less heat is radiated up to space. And instead, the atmosphere, because of these greenhouse gases, warms. Methane is a particularly potent greenhouse gas. And the combination of methane and carbon dioxide and other greenhouse gases, they warm up in the atmosphere, increasing the temperature of the atmosphere. And then some of that heat is radiated back down to Earth, increasing surface temperatures. So methane as a potent greenhouse gas is responsible for some of that warming. In addition, a concern that we have is that when ultraviolet light that's part of sunlight naturally interacts with hydrocarbons, those other hydrocarbons that are part of natural gas, ethane, propane, butane, you remember from the pie graph I showed you, those hydrocarbons and nitrous oxide or NO2, not nitrous oxide, but NO2, sunlight interacts with those molecules and leads to ozone at the ground level. Ozone is an extremely caustic gas, and it attacks biological tissues, especially vulnerable tissues like those inside of our lungs. And they can also attack the delicate tissues inside of plants, causing damage there. And so ground level ozone is an important pollutants that arises indirectly from the presence of hydrocarbons from natural gas leaks to the atmosphere. So this is a little bit of backdrop about the natural gas leakage pathways and how that can lead to elevated methane and hydrocarbons in the atmosphere. I'm going to hand the baton over to Grace Hood to talk a little bit about how human society in Colorado has been responding to these hydrocarbon leaks and how that's been unfolding in Colorado. So Grace, do you want to tell us about that a little bit?
Yeah. So let's start here. Let's travel back to 2014. This was a groundbreaking rule here where kind of oil and gas companies and environmental groups came together and said, hey, we want to stop that methane that Joe had mentioned from leaking from some of the oil and gas infrastructures. So it was really kind of a win-win for environmental groups and oil and gas companies. And that really launched work here. You see in this slide, I tracked in 2016, I followed this Anadarko worker, and she was looking for leaks. And Joe had mentioned this, the FLIR cameras. He showed you an infrared picture. This is, I mean, just this crazy piece of equipment. I think it's like $100,000, kind of looks like a camcorder. But they can use this piece of equipment to find methane leaks coming off of this very bizarre, kind of intricate looking oil and gas infrastructure. And the key thing back in 2014, and I filed this story in 2016, is that companies started to tell the state how many leaks they detected and how many leaks they repaired. So that's a huge deal. At the same time, though, we had residents, I filed this story here a year later in 2017. Residents are still unhappy. I want to introduce you to Dawn Stein. Take a look at this picture here. So to the right of this tree is her house. And to the left of her, you can see her fence line. And then you see sort of a tan wall, and that's where a drill rig was starting to be put in. And she was really raising concerns about air quality near wells. And so, you know, I mentioned that 2014 methane rule is a really big deal, but that was for wells after they had been drilled and put into production. Dawn Stein here was worrying about methane and volatile organic compounds that can escape during the drilling process when these wells are being put into place. And, you know, some volatile organic compounds have been linked with health issues. As Joe mentioned, they can also contribute to the production of ground level ozone. So we have health concerns being raised by citizens. We also have safety concerns. This picture indicates the Firestone home explosion that happened in April 2017. There were 2 people killed in this home fire. There was one who was severely injured. And that was part of what fed into this statewide ballot initiative that some of you may remember a couple of years ago. And residents back then who were proponents of this were saying, hey, you know, we want more space between wells and homes. And we're concerned about water, we're concerned about air. That ballot measure ultimately failed. But what's interesting is that the concerns registered with kind of 2 key bodies, a Democratic legislature and newly elected Governor Jared Polis. And here's a picture of this woman, Erin Martinez. She was in that Firestone home explosion. Her brother and her husband were killed. She was a very vocal advocate for signing of Senate Bill 181. And I really see that as kind of the most massive oil and gas reform legislation in a generation. I mean, Senate Bill 181 did so many things. You know, probably the biggest thing that you may remember is that it reformed the state regulatory body known as the Colorado Oil and Gas Conservation Commission. They have to take into concern, you know, some of these concerns that citizens have raised. But what's, I think, really important for this discussion is that it required more controls on restricting the release of methane and volatile organic compounds. So I think more and more we see states like Colorado stepping into the void where we see rollbacks at the federal level. We really see states like Colorado doing pretty significant work. For example, another significant piece of legislation last session was a bill that requires Colorado to reduce greenhouse gases. And one of those goals is 90% greenhouse gas reduction by 2050. I mean, that's written in state law. There's now a climate unit inside the State Department of Environment and Public Health. So I think, you know, between the oil and gas reform and this greenhouse gas reduction bill, I mean, that's a huge sort of victory lap. But what I think is interesting here is we continue to see citizens pushing for better ways to do things. I want to introduce you to Gabrielle Petrone here. She's somebody I met, just a brilliant scientist at the National Oceanic and Atmospheric Administration. And she really found that while there were these great legislative reforms, the way that the state was sort of gathering air quality data in, you know, from her vantage point, working at NOAA, which is sort of the premier institution for measuring greenhouse gases like methane, was lacking. For example, at the end of last year, she came to me and she said, "Hey, Grace, you know, I've been looking through the data that the state gathered." She was looking particularly at methane in Weld County, which is sort of the heart of oil and gas country. And she found that state data was saying that measurements in oil and gas country were lower than basically methane levels at the South Pole, which is known as the cleanest air on Earth. And that is just simply not possible. I mean, it's would be almost impossible to get that measurement. So I think she really held this up to the state and said, hey, you know, if you want to reduce greenhouse gases, you've got to do a better job at measuring them and taking that more seriously. And I think that the sort of amazing thing about this story is that state officials listened, and we saw more legislative reform here. State officials, the state legislature last week passed a bill that's going to put more money to measure things like methane and volatile organic compounds. It's going to tax air polluters to do more comprehensive air quality monitoring. And, you know, I think there's just so much going on right now. I just thought that was a huge deal, and it kind of got lost in the shuffle. But I think ultimately, if you're feeling bummed out about the state of federal affairs and all the environmental rollbacks, you have seen significant improvements here at the state level as far as air quality goes. But, you know, I think keeping methane in the pipe is just one solution. I'm going to turn things over here to Sybil Sharvelle, and she's going to talk about kind of a new emerging way that you can actually generate natural gas from a cleaner source.
Hi, thank you, Grace. Yes, so I will talk a little bit about renewable natural gas today. Just a second. So I want to make sure, can anyone confirm if I'm sharing my screen?
I don't see it yet.
You don't see it yet, okay. Let me get back to Zoom here. Oh, I see what's going on. Okay. It looks like it's on now. You guys see it?
Yep.
Okay, so thanks everyone, and thanks for the background, Joe and Grace. That was fabulous. I'm going to transition into talking about, we've heard some of the problems around methane, although it's, you know, a valuable source of energy. There's some issues around capturing and using it, and those are particularly relevant here in Colorado. So there's renewable natural gas, and when we think about renewable natural gas, that's the American Gas Association defines it as pipeline compatible gaseous fuel derived from biogenic or other renewable sources that has lower life cycle carbon dioxide equivalent emissions than geological natural gas. So Joe gave us a lot of background on the way that methane can serve as a greenhouse gas. And when we say these renewable natural gas streams and biogenic, what we're talking about often is making methane from some kind of biological source, and often those are waste products. And that's why we refer to this fuel source as being a renewable source, is because these are waste products that we generate that would otherwise have to be managed in another way, that we can instead conduct some process to convert those over into methane and perhaps use them as a vehicle fuel or resupply them into natural gas or into gas pipelines. Okay, so one common way that we use to do this is through anaerobic digestion. Anaerobic digestion is a biological process. It takes high carbon waste materials. You could use non-waste materials too, but anaerobic digesters are generally considered for processing waste materials like some of these shown here, food waste and municipal areas, even crop residues from crop production, yard waste that are generated, animal manure, toilet waste. These guys talked about methane as being their favorite gas. I spend a lot of my time thinking about poop, and that doesn't bother me too much, but but I've gotten used to it. There's also a lot of food processing facilities, like here in Fort Collins, for example, we have the New Belgium Brewery, and they take some of their wastewater from their process, so processed wash water that has a lot of beer waste in it, and generate methane using anaerobic digestion there. Milk processing facilities also generate waste material that can be really valuable to produce methane through anaerobic digestion. So there's lots of different waste materials. The main quality of those that makes it effective for anaerobic digestion would be that they have high carbon content. We take that high organic content waste material and put it into an anaerobic environment, and the microorganisms in the digester convert those over into organic acids, and then the acids are converted into methane. So in the absence of oxygen, these organisms form methane, which then can be used as an energy source. Okay, and then we have this methane biogas. The biogas, I call it methane, but it does have other constituents like carbon dioxide. The composition's going to vary depending on the type of waste material that's processed in the anaerobic digester. So we have to clean it up in different ways to make different uses of it, but depending on the type, so if we take methane biogas into a boiler, it actually requires very little cleanup. Generators, we have to a lot of times remove hydrogen sulfide that can be corrosive to the generator. We call this cogeneration because we use a electrical generator, but also produce hot water that can be made use of as well in the process. We can purify and liquefy to use the gas as a vehicle fuel, and we can purify to supply to natural gas lines. These two middle ones, the vehicle fuel and natural gas lines, are the ones that really require the most purification before we can make use of those gases. But there's lots of different ways, and really the way that these gases get used should depend a lot on the local needs. If there's industry nearby with boilers that they use for heating, that's the best way really, because then we don't have to clean up the gas very much. But there's many options, and it really depends on what the best local use is. We also make methane in landfills. Probably as you've driven by landfills before, you've seen flares. That's the anaerobic digestion process happening naturally in landfills where microorganisms are degrading carbon material, and because there's not oxygen supplied into landfills, we get methane out of those. Though that methane oftentimes is flared, but can be captured for use. So that's an important source of renewable natural gas potential as well. This map is from US EPA. It shows the projects where landfill gas is actually being made use of. So we have the purple show where it's being generated, like I showed, a generator is being used to form electricity. The green shows direct use, like, for example, something like a boiler. And then we have renewable natural gas pipeline injection, and then black is the local use, which would be something like using it for vehicle fuels locally or something. There's a wide variety. You can see our region and our Mountain West is pretty sparse as far as projects where landfill gas is collected and used. There are good reasons for that. This anaerobic digestion process requires the microorganisms work best when it's wet. We simply don't have the rainfall here in Colorado and the Intermountain West region to really keep the microorganisms in the landfill supplied with enough water and wet enough conditions to promote this methane production. So then putting in the infrastructure in to make use of that methane can be really costly, and unless there's some way to recirculate the liquid or something, it becomes too costly to do. But so people think more about ways of separating organic waste material in our region to create anaerobic digesters that can do this separate from the landfill. There's ways to operate landfills as well to really increase the methane production, but it does add an additional cost. So you don't see as many projects in this region. Here's some nice examples of projects. I think I mentioned direct use in vehicle fuels. This is a project in the Altamont landfill near Livermore, California, where they have used the landfill gas to make vehicle fuel, and then they use that to fuel the local transportation fleet. Similar project in St. Landry Parish in Louisiana, where landfill gas is used. You can see these vehicles over here, police vehicles, different vehicles. So all the different city vehicles come and fuel up at this natural gas station at the that's located by the landfill. So that's a really nice way to have kind of this very local use and decrease costs for a utility to do this. Okay, so let's kind of bring this back to some of the things that Joe was talking about with respect to carbon emissions and greenhouse gas emissions. One thing I should note is that anaerobic digesters, if they're designed properly, they should be designed without some of the leaks and things so that gas is adequately captured and made use of, and it's very difficult to make them economic or financially beneficial unless all of the gas is adequately captured. So we're capturing that methane and not letting it release to the atmosphere, and then making use of it to form some sort of energy source. This graph shows a study that we did for the city of Fort Collins, where we looked at landfilling organic waste versus composting it. So that would be making like a compost that you would put on your garden that's high in organic matter. And then AD is anaerobic digestion. So we've got blue is the anaerobic digestion, green is composting, red is landfilling. And this y-axis requires a little bit of explanation. So these are normalized values. So basically where you see 100, so let's just take, for example, landfilling and the respiratory inorganics. That means that landfilling creates the highest amount of respiratory inorganics, and that, for example, composting creates about 65% of what landfilling does, and anaerobic digestion about, just under 60% of that. So it takes the highest value. This doesn't show relative values, rather it normalizes to whatever produces the most. Okay, so what we can see here, and this is important because some people don't think of anaerobic digestion or generating methane or energy from waste materials as being a clean energy source, since it still creates carbon. But if we look at these things in terms of the next category over is climate change. So this is the climate change impacts. If we have these waste materials and food waste and things, if we landfill them, that is the way that we generate the most highest impact to climate change, meaning that we create more greenhouse gas emissions that impact climate change. And then anaerobic digestion substantially decreases those. And then if we look at the last category, which is fossil fuels, we see the anaerobic digestion of this waste material also has a benefit to reducing fossil fuels. And a lot of that comes because of the fertilizer that the digestate can be used as fertilizer afterward, and fertilizer like adding nitrogen and generating nitrogen and phosphorus for land application requires a very large amount of fossil fuels. So we get fossil fuel savings when we do these processes. So there's a lot of benefit in terms of thinking about greenhouse gas emissions, even though we're still generating methane and thinking about and having carbon as being an energy source. This graphic was done by also American Gas Foundation, and this sort of shows us the potential for renewable natural gas looking up to the year 2040. There's a low resource potential and a high resource potential. I want to point out the dotted line along the top shows our residential consumption based on a 10-year average. So that's kind of where we are right now in terms of natural gas consumption. What this graphic does show us is in the high resource potential scenario that we can get pretty close to meeting current natural gas consumption. There's a lot of uncertainty in these estimates, though, that comes from how much waste we actually produce, how much our population grows, how much waste gets landfilled, all of these kinds of things. And ultimately, we want to try to reduce our waste production as much as possible and not produce as much food waste as we do currently. But as long as society is functioning, we will have some food waste. We'll definitely have animal waste, animal manure waste, also human waste that can serve as an important source of organic matter in anaerobic digesters. So there's kind of a large band of how things could look moving forward for how much renewable sources could contribute to our natural gas portfolio. And it depends a lot on how we manage things and how our population grows. So with that, I'm going to hand it back over to Joe to provide some summary here and let us go into some discussion.
Thanks, Sybil and Grace. This was fabulous. I had to mute myself. Any of you who have ever lived in Fort Collins know what happens when the trains come through town, or when your building is right next to the train tracks. You can, hopefully it's past far enough so it's not part of the conversation. Sybil and Grace, I thought this was fascinating about the societal angles and how technology and society interact to yield these phenomena. I mean, we can imagine developing a series of widgets that carries natural gas from the ground into a home or business and provides energy. And then the unintentional release, the sort of non-engineered features of what these systems and the way that human societies have to interact from a health perspective, a climate perspective, safety. I just think it's fascinating to try to tease these apart and try to solve some of the problems that our technology is starting to create. Renewable natural gas points us clearly in that direction as an opportunity. So thanks to Sybil for helping us to organize that. I wanted to give Dan a chance to speak. And Dan, I know that you've been working in the area of trying to work with Colorado Oil and Gas, the COGAT situation, and how some state entities are measuring their emissions. Can you talk a little bit, Dan, about your familiarity with how the state is taking action to quantify emissions?
Yeah, sure. And I'll try to answer one of the questions that's up on the list about international effect as well, from one of the questionnaires, one of the people who asked a question about the guidelines kind of internationally as well. Where we are right now with the natural gas industry, which is where I'm more familiar with, not the space really that Sybil was talking about with landfill and the like. There's a big push on developing solutions to detect leaks and then to respond to those leaks. The topic that Grace talked about in Colorado with the regulations is actually happening a lot of other places. And because there's such a push on doing that kind of leak survey, finding the leaks and the like, there's a big investment coming in techniques that are going to make that easier, or at least make it more comprehensive. If it's not cheaper, it's certainly something that would operate, 24/7 instead of just small parts of the year or small parts of the time. And what we're seeing now is more interaction between parastatal type of organizations across the world on how to develop an environment where solution developers who are putting money into these solutions can get them out broadly. And so in my particular research area, we're testing a lot of those solutions. When we put out a call for people to be on a protocol development committee for developing protocols to test leak detection solutions, we have, I think at the latest count, like 67 individual entities who are providing some kind of comments on how those solutions should be tested. And that, to me, is a really good gauge of people's interest in rolling out better leak detection solutions and putting those into kind of a regulatory context where the companies can feel like they are doing the right thing, and the public can feel like they have some insight into what's being done. So I recently met with the European Commission on this topic as well. So they have a different problem than the US. The US, we have a lot of domestic production. In Europe, they're purchasing from outside of Europe into Europe. And so they're looking at ways to kind of supervise the whole supply chain that's leading into Europe, and how to cascade those things out to international kind of purchase agreements as well. So there's a little bit of difference between different countries and kind of how they're approaching it. But I think everybody's looking for a stack of technologies that will help them inspect that, whether it's down at the individual component level, all the way up to satellites going over the top and looking for large emitters.
Thanks, Dan. I mean, it is a fascinating technological development. And Grace, are you familiar with what Senate Bill 181 requires for quantification and how far along we are with meeting those requirements?
Well, Senate Bill 181, man, it just reformed everything. As far as the methane goes, one of the things that it did really start to look at, it has to do with when wells are drilled, and right at the moment that they go into production, there was what some environmental groups were referring to as kind of a 90-day loophole, where they didn't have to monitor the volatile organic compounds that were coming out of the well. And that's that loophole, or whatever you want to call it, has since been closed. But I mean, boy, there have been so many rulemakings out of Senate Bill 181. It's just been sort of a phenomenal landscape to look at as far as regulation goes. I mean, one of the things I actually wanted to ask Dan is just, one of the things I failed to mention in my presentation is we had a slide that looked at the Firestone home explosion. And out of the settlement of that Firestone home explosion is $18 million that's going to be going into research looking at how to better detect methane leaks. And Dan, I think part of your work is going to be maybe focusing on a chunk of that. What exactly are you going to be doing?
Yeah, actually, we're doing quite a bit of work as a result of that settlement. Thanks for the question, Grace. So one area we're going to focus on, this is all pending contract, but assuming it moves forward here fairly quickly, one area we're looking at is better detection methods for underground pipeline leaks. So the problem with the actual Firestone explosion was because of an underground pipeline leak. But in general, the techniques for finding leaks above ground don't translate directly to finding leaks below ground. And particularly when you have heavy hydrocarbons like propane, ethane, and beyond in the pipeline, where they're heavier than air and they might migrate down instead of up. That requires some different considerations of how you would detect the leak. So that's one project. And then the second area we're working on is what's called a coordinated campaign. And so part of the problem with every state's regulation process right now is that the reporting method for leaks is not well correlated to what you see when you look at an entire basin. So when you measure the basin's emissions, you end up with a number that's, give or take 1.5 to 2.5 times larger than when you try to count up all the individual sources. And so one of the things we're going to also do as part of that is to try to understand how often large leaks occur, where they occur, what their persistence is. And so we're going to do a measurement campaign that's going to include aircraft flying overhead and people on the ground making individual measurements. And I think there's one question that's queued up right now about industry self-reporting. I don't know if you can see that, Grace, as well. You might be able to comment on it. But, I think this is part of the trust but verify, to quote folks from my youth, is that I think what we're going to is sort of a regulatory process where we want companies to be responsible for their own operations because they can do things faster and sometimes a lot more cheaply than external inspections. But you still have to have some type of an overview to understand that if the regulations you put in place, it's not that people don't comply with the regulations. It's, did the regulations produce what you wanted the outcome to be? And I think that we're going to that kind of hybrid approach right now. And that's part of what we're going to test in the study.
Well, and I think one of the things I'm just really curious about is the technology that's just changing so significantly now for detecting some of those leaks. I mean, I wonder, Dan, if you have a sense in 5 or 10 years, how might oil companies be detecting leaks and how different? Is there still going to be someone with the camcorder type thing trying to measure leaks, or is it going to be just all done by satellites? I mean, what are your thoughts on that?
Well, so I think you have to divide it into two bits, okay? So right now, when we go out and measure leaks in the field, about half of the emissions come from a handful of large leaks. So if you want to move the needle on emissions, go after the big things. And in fact, if Sybil answered the same question for landfills, she would say the same thing. Go after the big landfills first, because you can move the needle faster. And those, I think that technique is, or the continuous monitoring techniques are the way to go after that, right? So if you are getting quick notification of the large emitters, you can tamp them down earlier. Now, the thing is that those continuous monitors aren't going to tell you exactly what went wrong. So you're going to still send people out with cameras or sniffers or something like that to isolate the problem and fix it. But I think that where we're going to be 10 years from now is probably that the bulk of the leak detection will be continuous and it will catch all the big things. And then you'll do some routine kind of maintenance type checkups later on. That said, the big way to move emissions, and I think it's one of the kind of hidden stories here, is that companies are going to new operational designs that after the well site is moving gas or after the compressor station is pumping gas, they're going to new designs now that are inherently lower emission. And that's really, if you really want to look forward, to the rollover of infrastructure over a 10 or 20-year period, that's the biggest needle of all. It's kind of design things with that in mind right up front, with the emissions mitigation as part of the original design of the site.
I wanted to throw the ball to Sybil and Dan about, Sybil, in your last graph, you showed some future projections for natural gas. And we have a couple of questions on the Q&A list about one, Sybil, your bar over time was constant, as if the sort of total natural gas demand was going to be, that dashed line was relatively constant. And I wonder if you and Dan can comment on that. And second, maybe more towards Sybil, if you wanted to, some of our people in our SOGIS audience might be interested in how they could advocate for increased use of renewable natural gas. What are some of the barriers that people can locally work to overcome within their communities to enable better use of RNG?
Okay, so I can take the first part and I'll pass it over to Dan on that bar being flat. that graphic was generated by American Gas Association, and they did assume, based on the 10-year average, that it's staying the same. I think that we could likely see a large increase in use of natural gas. Some of the same things that drive more waste to be produced, like population increases, are going to also result in energy demand increases, and we can think about efficiency there as well. I think there's a lot of uncertainty in that dotted line that I presented as well. Dan, anything to follow up on that?
Sure. So let me answer one of the questions directly, which was, do we expect the natural gas dependency to grow in the future? It's important to understand that the reason people are punching holes in shale right now is not for gas. Okay. The holes that are going in the ground right now are primarily after liquid fuels, which are much more valuable. And the gas is a co-produced product. There's only a handful of plays out there where people are going expressly after gas. The vast majority of the investment's going after oil. And so because of that, gas prices have been very low. And when gas prices are very low, it's attractive for electricity generation to switch from other fuel sources into natural gas. The line that Sybil showed was for domestic use, residential use. The actual use of gas is going up quite rapidly, and a lot of that is in electric production, and a lot of that's driven by the fact that it's lower cost. And I think somebody else asked about it, is there regional differences there? And the regional differences are dramatic, right? So in the US, we have a large domestic oil industry, and it really is oil, right? It's liquids focused. And then the natural gas is available, so it is low price and easy to get at. In other countries where the natural gas is being shipped in, natural gas does not like to travel long distances easily. And so there's much less emphasis on natural gas.
Yeah, if I could
There was also a question about accurate maps of gas pipelines and wells. That's an entire one of these sessions by itself. But yes, there's a plethora of data out there that is varies in accuracy, and it does help some.
Yeah, and I'll just follow up on what Dan mentioned with the respect to the value of methane as a natural gas source and anaerobic digestion. This also gets to another question that someone asked about, do we have to take the organic material to methane, or are there other ways we can make energy from anaerobic processes? And there's a lot of ongoing research right now on how we can use the organic products and stop before we make methane and generate these volatile fatty acids that can be used to make liquid fuels that have a lot higher value. So that's another way that we can think about using these waste products to form valuable products that serve as energy sources that aren't methane. So that is an important consideration, I think.
So
Joe should go ahead.
You can also get other products out of the digestion, right? That are actually quite a bit more valuable than fuel, right?
Right. So if you operate an anaerobic digester as a complete resource recovery system, which is really what we like to think about, then you would be capturing nitrogen and phosphorus from that system. And there's ways that you can make that very valuable for farm production and on the market value. You can also use the solid digestate to make, some people, you may have heard of cow peat. That's a product that you can buy that is essentially, it replaces the moss peat products that you can buy as soil amendments, and those can be very high value products as well. So there's a lot of ways that we can generate other high value products from the waste materials other than just the energy products. And the volatile fatty acids can be used to make plastics as well. So there's many potential products that we could make from waste materials in these processes.
We had a great question here about what are some of the gaps in regulation that currently have in natural gas regulation in Colorado. July 1 is a big deadline for the rulemaking Sybil and Dan, or I'm sorry, Grace and Dan, do you want to comment on that? Do you see any holes or any contention coming up in the rulemaking deadlines?
Grace, you can go first on that one.
Sure. Well, I think the devil's in the details. I mean, I think Senate Bill 181 was so comprehensive. It called for some really amazing strides, but I think really it's going to be what's in the actual final rules. And I know that, for example, you know, the mission change for COGCC, when that's actually written, there are certain particular issues that I know oil and gas groups are tracking kind of more closely and are going to be more hard fought. And I think it's still really, we won't know what that final result is until it's voted on by the COGCC. So I think absolutely I'm staying tuned.
I'm so overwhelmed with the number of rule changes they're making. I literally hired a political science student to track it for my group.
Really?
So, yeah. So if people feel like it's hard to keep track of, you know, rules from everything from inspection requirements to new pipeline coatings to all that sort of stuff, I have to say I admire the regulatory bodies in Colorado just to keep all these balls in the air, and the industry folks to kind of keep track of everything. It is moving really quickly.
Yeah.
It's exciting. The technology, I think like, as you said, Dan, the technology and what we can hope to learn from it. Different devices allow you to find leaks with greater or lesser efficacy. The harder you look, the more you find. Sort of understanding the strengths and weaknesses of different devices and work practices, I know, is an active area of research for both of us. And so I always think about Mr. Spock standing on the deck of the Enterprise, you know, scanning down and understanding the sort of whole function of a planet. And in some ways, you know, every year we take a baby step in that direction, and understanding sort of the strengths of the devices for telling us about it, and then also the analytics for revealing what we have learned and what we haven't, and characterizing uncertainty. Sort of the interplay between technological development, uncertainty, and policy is just a fascinating place for us to be. Sybil, I did.
And in fact, I think the conversation I've been having with the regulatory groups in Colorado is one of some caution, right? So, for example, the continuous monitoring idea is I think where we're going to end up in 5 to 10 years, but it is not completely baked yet. And it's very possible to end up in a situation where you think you're measuring something and you're not really measuring. And so I think the direction they're going to go on, for example, continuous monitoring is you know, to step into it in stages where they first start to collect data, then make sure they understand how it's working, and then move forward. So some of the things they're doing are just obvious best practices that can be rolled out right away, and others are more exploratory.
Mm-hmm. Yeah, exactly. We just have a few minutes left. Sybil, I did hope you would touch on this question about advocacy. You know, what are the barriers to RNG entering into different geographic areas? If we just focus on Colorado, for example, how can people advocate for RNG production and use in their area? What are the barriers?
Yeah, I think the largest barrier is around finances. It's just simply not cost effective right now in our current climate to produce these gases and make use of them. I talked about like how in our Intermountain West region, we don't see very many of the landfill gas capture and use because it's really costly to put in that infrastructure, and then there's not quite enough gas getting produced to make use of it. These are very costly projects is the reality, and then the buyback price for methane or energy sources are generally low. So a lot of places where you've seen some success is where you can buy, like for example, I think it's Vermont that has you can buy cow power. Like here you can maybe pay a little bit extra on your energy bill to support wind or solar energy projects. Same thing there is that you can really pay a little bit more for your energy to support some of these renewable energy sources and renewable natural gas. I think that's one way, but also for municipalities and cities to really think about what are the solutions that are really localized and make sense in that area. This New Belgium project has been fabulous. They, they operate their anaerobic digestion system very cost effectively and make use of, they supply the energy that they produce during peak hours. So that helps them with their finances. So finding really local solutions that fit with the community, I think, is a really key part of making these projects successful. So thinking about what are our local energy needs, what are our local energy sources, and how are we producing those energy sources in terms of what are some of the local waste products that we generate a lot of that we can make use of. So really thinking about those and how we can find the synergies, I think, is a large part of project success.
Super. Well, we're near the end. Are there any last comments that our panelists would like to make?
Well, so there's a question about citizen science.
Great.
And so, good idea. Be careful that you know what you're measuring. It turns out measuring this stuff is actually kind of expensive. And so I'd be interested in having a conversation with anybody who is interested in the citizen science aspect, because I think there's nothing like knowing to be empowered, but knowing does require some care. So, Grace?
Yeah. Well, you had mentioned citizen science. I think one of the most fascinating developments I've seen over tracking methane leaks is sort of an announcement by the Environmental Defense Fund, where they said, hey, we're going to launch a satellite to measure methane. Now, this is obviously not somebody in their backyard, trying to measure methane. They're hiring Ball aerospace scientists to build sensors and so forth. But I think it speaks a little bit to that citizen science, because as I understand it, they're going to be putting that data out there for people to look at and analyze. So I think that'll be a very interesting thing I'll be watching there.
Well, we've reached the end of our hour. I want to thank SOGIS for facilitating this. I would like to invite the participants who are watching this to write into SOGIS. They may be mad at me for a flood of email, but go ahead and flood them with other ideas where there are topics that you felt we'd like to hear more about here, or other SOGIS panels that you'd be interested in eating lunch in front of, or typing in a couple of questions. We'd be happy to do more and to address what the community is interested in. Well, thanks again to Dan, Grace, Sybil for participating in this. Thanks to Laura Shaver for organizing it. Thanks to SOGIS for their interest in supporting these kinds of conversations. I hope that you all stay healthy. I hope that you could do what you can to promote a sustainable environment here in Colorado or wherever you are. So I'll say thanks and goodbye for today.
Thank you.